Good morning. In this video, we're gonna talk about time, velocity, and speed through these practice problems here from OpenStax College Physics. Okay, let's take a look on problem 6. A helicopter blade spins at exactly 100 revolutions per minute. Its tip is 5 meters from the center of rotation, and we are asked here to calculate the average speed of the blade tip in the helicopter's frame of reference, and in part B, the average velocity over one revolution. So let's solve first part A. The average speed. Now again, average speed is just total distance traveled over total time. So we will have it here. Speed. I'll just put it as speed average total distance traveled. Okay, over the time that distance is used to travel that distance over total time. Okay, so based on the problem, I think it is clear that in 1 minute, okay, according to the problem, the helicopter blade spins 100 revolutions in a minute. So if you just have a basis of 1 minute of time, okay, the helicopter blade will be able to travel 100 revolutions. Now note that revolution is not a unit of distance, okay, and look at this. For example, if this is how it looks like, this is the center, and this is like the propeller blade of the helicopter. Now, this one is what? This is the tip of the blade, and when this rotate, it will trace a circular path, right? It will somehow trace a circular path. It's not that circle, but somehow just like that. And note that every revolution, I hope you can still remember that the circumference of a circle is 2 pi r, and therefore the circumference of that circular path will be what? 2 pi times 5, r, the radius is 5. It's 5 meters from the center, so it's 10 pi meters. Meaning one revolution will be able to what? One revolution is 10 pi meters equivalent distance, right? So 100 revolutions per minute will mean what? 100 times 10 pi meters. Okay? I hope you follow. So all in all, it will be what? 1000 pi meters per minute. Okay, but if you want to convert this again to seconds, it will just be as simple as meter per second, standard SI unit. Let me show 1000 pi meters per minute. Multiply that by the conversion, which converts minutes to seconds. 1 minute is just 60 seconds. You will be getting a what? Let us see. Let me evaluate pi as what? So 1000 times pi divide by 60, okay, and it's giving me a 52.36 meter per second. So that is my average speed of the blade tip. Okay, now for part B, we're being asked to solve for part B. Again, part B is the average speed. Okay, the average speed is just change in displacement with respect to time. So if we here, according to here, is just over one revolution, meaning one revolution. Over one revolution. But the idea here is that if this point here is able to complete one revolution, so you can see one full circle, delta x will just be 0. I hope you understand that it will be 0 because you start from that position and you make a full circle and you end at that exact position, meaning displacement. There is no change in position, so displacement of 0. We don't know the time exactly that it will take you for 1 minute, but never mind that because that will just be 0 also. V average will be 0. So in this case, average speed is 52.36, but average velocity is not the same as magnitude of average speed because again it's not a linear motion, it is a circular motion, and sometimes it might be counterintuitive, but the average velocity here tends up to be 0 because in a full circle, in a one full revolution, the point, the tip of the blade goes back to its original position, making v average 0. Now, how about in problem 9? Well, in problem 9 here, in May 26, 1934, a streamlined stainless steel diesel train called the Zephyr set the world's nonstop long-distance speed record for trains. Runs from Denver to Chicago took 13 hours, 4 minutes, and 58 seconds. And of course, it's able to travel this distance. So average speed, well, we're being asked for average speed. So I think this is no longer a big deal because average speed, we already know how to solve for it. It's just distance traveled over time. So we're asked for kilometer per hour first. So how many kilometers? 1633.8 kilometers. But the time here is the crucial thing in this problem is that we should know how to handle time units. In this case, time is given in terms of hours, minutes, and seconds. So the good thing to do is convert everything to hours. So meaning what we have here is 58 seconds. We need to convert that 58 seconds to hours by using the conversion that, well, you can just directly convert. Like, I think you need to memorize this formula. I mean, conversion. 1 hour is 3,600 seconds, just to make you faster, not going to the minutes. So 58 divide 3,600, that will be 0.06111. 0.06111 hours. How about that? 4 minutes. Well, the 4 minute thing can be converted to hour by just using the conversion. 1 hour is 60 minutes. And that will be 4 divided by 60. Okay. That gives me a 0.06667. I normally use as much as possible as many decimal places that I can use. Okay. Just to what? Do not fall into rounding off error that much. So hours. So if you add all of this, I add that to 0.06111, and I add that to the 13 hours so that I can have a total time in hours. It will now be 13.1278. Okay, around up to that point. So in hours, it will be 13.1278. Okay, I think that's good. 13.1278 hours. So the speed, average speed in hours will be that thing 1633.8 divided by 13.1278, and that gives me 124.45. 124.45 kilometer per hour. Now, if we are asked here to convert also to find also the average speed in terms of meters per second, well, we can just convert 124.45 kilometer per hour. I mean, no, no. We should do more decimal places. Instead of 0.45, I will write 0.45334. I'm doing this so that I will have a minimal error in rounding off, since that's not yet our final answer for the moment. So how do we convert that? The kilometer, we convert that to meter. So that's what? Meter on the bottom. And the conversion is 1,000 meter to 1 kilometer. You need to memorize conversion factor, the basic ones only. And then the hours. So 1 hour, 3,600 seconds, right? So if you do the math for that, this whole thing times 1,000 divide by 3,600. Okay. Oh, okay, good. And that will be 34.57. Okay, 34.57 meter per second. So this is, of course, this is a 1934. The fastest train supposed to be, and I mean long distance train is only traveling at this speed. Not that fast, but well, at that time maybe this one is fast already. So I hope you learned something in our discussion for time, velocity, and speed. So take a look on some other videos to this as we discuss more on the OpenStax college physics problems. Thank you.